Now in this question, if we read it through, we're being asked to calculate basically a precipitate calculation. We're asked to show by the addition of silver nitrate or a separate one, lead nitrate, to 9 litres of blood. So obviously for any concentrations we're dividing by 9 rather than to make sure it's moles per litre, and which will result in a greater mass of metal staying in solution, so staying as ions. Now, so we're given the Ks for silver chloride and lead chloride, so basically this is a case of the silver ions combining with the existing chloride ions in the human blood, which we're told that's the concentration, so that doesn't vary, or the lead ions combining with the chloride ions. So we need to set this calculation up and go from there. So if we set this out again, first of all we're going to turn the grams per litre into a concentration for the chloride ions, and that's going to go into this part of the Ks calculation for silver, and for the one for lead obviously it's going to be squared because we've got 2 of those. It's going to go into that one, so we need to work out the lead and the silver concentration next. Now we're told that it's 5 milligrams in both cases, so for instance the silver one we're going to be dividing that into grams per mole, and that's going to give us the number of moles, and then we're going to divide by 9 to have moles per litre. Now in the silver one we have 5 times 10 to the negative 3, and that comes from the fact that we're told we've got 5 milligrams, and a milli is 1,000th. We're dividing by 170 because that's the molar mass of silver nitrate, and we get 2.94 times 10 to the negative 5 moles, and we divide that by 9 because it's 9 litres, and that gives us a concentration of 3.27 times 10 to the negative 6 moles per litre. So in the second one, which is for lead, we've still got 5 milligrams. We're dividing it by the molar mass of the lead nitrate. That gets this number of moles. We divide it by 9 litres, and we get 1.68 times 10 to the negative 6 moles per litre. Now we can use these to put into the actual calculation. Now if we do that calculation, remembering that the chloride ion is squared for the lead chloride one, so that gives us, this is the ionic product, and silver chloride, it's just multiplying them together. We can make a comparison with them. Now the silver chloride Ks is 1.6 times 10 to the negative 10, and that obviously is much lower than this. This number is bigger, so we would get a precipitate in this situation. Then in the second case with lead chloride, 1.78 times 10 to the negative 8, this number is much smaller than the solubility product, in which case there won't be a precipitate. So there will be in this one, and there won't be in that one. Now we've got to look at the actual question, and it says which will result in the greater mass of metal ions remaining in the solution. And if this doesn't precipitate in the case of lead, which it doesn't, that means the ions will stay in the bloodstream. And that's that question answered.